Hello friends, welcome back to the channel. Moore's law is alive with high NA-EUV lithography. Now what is Moore's law? Moore's law says that the number of transistors doubles every 2 years in a particular chip. So Gordon Moore, the co-founder of Intel, proposed this law in the year 1965. And it is even after 50 years, the Moore's law is alive. But people say that it is dead. So there is a controversy. NVIDIA in the year 2022 said that Moore's law is dead based on their GPU progress. But Intel told that Moore's law is still alive. Now today we'll talk about Moore's law. We discuss about this. We discuss about lithography because there is a connection between lithography and Moore's law. Lithography is a process by which you can actually put a print on wafer, the chip of VLSI. That means by controlling lithography, you can control the tininess of a chip on a wafer. So as we progress from 7 nanometer to 5 nanometer to 3 nanometer and beyond 3 nanometer, it is extremely difficult to make the chip with correctness and good yield. And with traditional lithography, it is very difficult to get a high yield. Yield is basically the success rate for the chip manufacturing. So we'll discuss about this. So this is just to give a brief idea about semiconductor manufacturing, how semiconductors are manufactured. Semiconductor manufacturing starts with the cutting of silicon wafer. So silicon are basically come in the form of cylinder and they are cut into slices with 99.9% purity. Then that slice of the semiconductor is made with deposition. The next step is basically the photoresist coating. It is coated with some photoresist material so that some of the portion of the wafer becomes soft or soluble when exposed to ultraviolet light, and other portion of the wafer becomes hard when it is exposed to the light, ultraviolet light. Next stage is basically lithography, the most important phase of semiconductor manufacturing. By this phase, it is decided that what is a how much small a chip can be manufactured with the help of lithography. Then after the lithography, there is etching, by which it is basically cleaning process of the unwanted material, and the 3D part of the chip is being kept on the wafer. The next step is basically the packaging, which is very important, by cutting the wafer into small tiny chip and packaging them with some interconnect. So this is all about semiconductor manufacturing in brief. If you have not gone through my previous video about how semiconductor is manufactured, please find this link here. So next, basically we'll talk about lithography in some more detail because lithography is very much contextual in this video. Now, what is lithography? Lithography is nothing but a ultraviolet light is basically passed through aperture and put on the wafer surface. Now this aperture is very tiny in size, and ultraviolet, and there is a blue print of the chip design is put on the wafer. So light comes here, there is a wafer out here, there is a blueprint of the design that needs to be manufactured in the form of a chip, and then it is projected on the wafer side of the things. On the wafer, there is a print of the wafer, print of the chip is being formed on the wafer, and this is the whole process of lithography. But this ultraviolet ray does not come directly, it comes through different angles with different mirrors. And most importantly, there are lithography machines out there which basically carries out all these kind of tasks itself. So first generation of lithography is basically EUV lithography. EUV lithography has came, I think, around 2010 time frame. And at that point, with the help of EUV lithography, it was possible to make, I think, till 7 nanometer of the chip. It was possible. Because I remember that with EUV lithography, there is companies like, we'll talk about in more detail, but Hui has been able to make 7 nanometer chip with EUV lithography. Now, we move from EUV lithography to EUV lithography because if we need to make the chip further small beyond 7 nanometer, it was required to modify the lithography process. Now, EUV lithography, in EUV lithography, is basically there is two ways by which you can control the more transistor, how more transistor can be accumulated in the chip. First knob is basically modifying the wavelength of the ultraviolet light. that is being used in the lithography process. The second stage is basically the second step by which you can modify the smallness of the chip is basically by controlling the aperture size. So from DUV to UV, there is a significant difference. It was 193 nanometer wavelength of light was being used compared to UV lithography, which is basically using 30.5 nanometer. So there is a huge difference, and this is the norm by which the new lithography machine has been configured from DUV to UV. And with UV also we can do till 3 nanometer, but beyond 3 nanometer it was not giving a good yield. So there is a requirement of high NA-EUV. How high NA-EUV machine is basically required for 2 nanometer and below 2 nanometer chip manufacturing. So what is the process? Here basically NA signifies that numerical aperture. So the numerical aperture size has been reduced considerably in the high NA-EUV machine. So this is the story of the UV machines, and we basically know that which is basically the high NA-EUV machine, and with the help of this the transistor size has been reduced by 1.7 times in the UV lithography, and I think around 2.9 times density has been increased with high NA-EUV lithography process. Now, next and most important thing is basically what is the real world impact of lithography, specifically high NA-EUV lithography. So, ASML is a company in Netherlands who prepares this lithography machine, and this is an extreme costly machine. I think one machine cost around $400 million, and they have recently exported 5 machines to Intel, TSMC, and Broadcom. So these companies already possess these high-tech machines right now. Intel has told that the next node which will be coming, I think 18A will be coming in 2025, but beyond that they have a plan for manufacturing 1.4 nanometer chip, and they are going to use these high NA-EUV lithography machines. TSMC was evaluating this new lithography machine, and they have recently confirmed that they are not using new lithography machines for some constraint out there in the process, and they will be using the old process because they have found that with normal UV machines they could find 90% yield that is possible for 2 nanometer chip. So I think they have the process, and somehow they have tweaked it so that they can use these same machines for the 1.4 nanometer things. Now you may have a question that how is it possible? This is possible with the help of basic methodology of lithography. So what happens is that the yield, the success rate of the chip depends upon how the imprint of the chip is being put into the semiconductor wafer. So it is a trial and error kind of combination. So basically, even if you put the correct blueprint of the chip in front of the aperture and you pass the UV signal to the wafer, it may not project to the correct print on the wafer side. But if you do some modulation of the blueprint by which you can get the correct print on the wafer, that is called trial and error approach. And recently, artificial intelligence has also come into the market, which can tell that what is the best combination possible between the aperture and then the blueprint of the chip and the wafer. In that way, you can improve the yield rate of the chip. So that is done, and so this is the story of Intel and TSMC, and then next is basically the Broadcom. Broadcom is basically, we not hear much about this, how they are progressing. They are making 2 nanometer chip, but whether they are using high NA-EUV or not, that is not very clear at this point of time. So, and recently we also trying to make a 3 nanometer, 2 nanometer chip. They are using the DUV lithography, but the thing is that there is due to some sanction from the US, they are not being able to get the high NA-EUV machine. So what they are doing, they are modifying the process by which, if it is possible by in different ways, they are trying to achieve this 3 nanometer, 2 nanometer chip manufacturing in their side itself. Now let's do a recap of what we have discussed today. We have discussed about Moore's law. We have discussed about the feasibility of the Moore's law. Some people are saying that Moore's law is dead. Some people are saying that Moore's law is alive. In today's video, we discussed that with the help of high NA-EUV lithography process, Moore's law we can declare as alive, because further shrinking of the transistor is possible with the help of this latest lithography technology. We also discussed about the semiconductor manufacturing in brief. We talked about in detail what is the lithography process. We talked about different types of lithography, which is EUV lithography, EUV lithography, and High NA-EUV lithography. We talked about, most importantly, the real world impact of lithography. We talked about Intel, we talked about TSMC, we talked about Broadcom, and we also talked about that what is the next node which is coming, which is 1.4 nanometer by TSMC and Intel. TSMC is not using High NA-EUV at present, but Intel has declared they will be using High NA-EUV machine for the next node. We also talked about UAE, who are trying to do some different way to get manufacture 3 nanometer and 2 nanometer chips. So this is all that I have discussed today, discussion. Now, based on that, what is your thoughts? If you are, I know that some of you are part of the semiconductor manufacturing process, so you can give some comments regarding this. What do you think about this? Whether do you think that Moore law is dead or alive? Whether you think that this High NA-EUV machine is just exported to these top chip designing companies? Is it going to be a success to this world, semiconductor world, or do you think that people will still believe on the old machine because of the experimented high yield that has been obtained, for example, by TSMC, which is 90% with this old EUV machine itself? So provide some comment in the comment box, and also most importantly, if you are a curious mind, if you are a curious audience, so please, you may have some questions, please drop some of your questions in the comment section of the video so that I can take it up and discuss in my follow-up videos itself. And yeah, I think if you have liked this video, please press the like button, share the video for better reach, and also subscribe this channel if you have not subscribed this yet, because in this channel I discuss all about semiconductor and artificial intelligence and different topics related to this. And last but not least, I would like to share that recently I have published a book. I have authored a book called Semiconductor for All, and this discusses about semiconductor topics and also artificial intelligence. It also discusses about semiconductor manufacturing stuffs out there, and so I think this is a good book to read, so you can buy it in Amazon. I will provide the Amazon link in the description section of the video. So yeah, I think that's it from my side for today. Wait for the next video to come. Till then, Subhasish Chakraborti signing off.